Hello data scientists, welcome to Skillgate. In this video, we'll do an age, gender and emotion detection project using CNN-based deep learning end-to-end. We have been able to achieve crazy industry-grade model accuracies with this computer vision project, which makes it better than any of the project you would find online. And it's actually 3 projects in one, wherein we have 3 separate models, one each on age, gender, and emotion detection. If you are new to machine learning or recently started working with image data, I would highly recommend you to go through our face recognition project as well, where we have used traditional machine learning to solve a relatively simpler computer vision problem. Link to this is in the description part below, so do check it out. For those of you who don't know us, we are Skillgate, and we are on a mission to bring you application-based machine learning education. We launch new machine learning projects every month, so make sure to subscribe to our channel to get access to all of our ML projects. Alright then, let's get started. This is our problem-solving framework. We'll go step by step through this to understand, solutionize, and deliver on our project in hand. So let's start with understanding a business problem that we would solve using our age, gender, and emotion detection project. Let me start off with a question. When was the last time you visited a retail store? Very recently, right? Retail stores are all around us. There are innumerable stores selling groceries, medicines, clothes, essentially just about anything. And based on what a store is selling, they maintain stock of items that an individual coming to their store may demand. From an operational standpoint, every morning the store opens. People come to the store, called footfall in business language. Some part of this store footfall manages to find what they are looking for and end up buying, shown in green and yellows here. Remaining come out empty-handed without making any transaction, shown in red here. Among these greens and yellows, the difference is on the amount spent. Greens do high value transactions, whereas yellows do low value. Now, of course, the store would not want to see any red among the people coming out. However, in reality, it seldom happens. Also, the store would want all of their visitors to come out as green. And that's even more challenging to achieve. In retail business, these desired outcomes of reducing the red and increasing the green are proper terminologies. Reducing the red translates to increasing conversion rate, which is the total number of transactions divided by total footfall. Increasing the green translates to increasing average transaction value, or ATV, which is total sales revenue divided by total number of transactions. So intuitively, more green here leads to higher ATV. So the business problem for us is pretty simple. We just need to ensure whoever enters into the store ends up buying. Simple, right? Actually, it is not. Let's take a step back here and look at this problem again from a data science lens. Any person entering the store offers a lot of information for us to analyze. For example, age, gender, facial expression, time of visit, frequency of visit, etc. Majority of traditional retailers do not bother capturing this information at all. So they essentially do not understand the demographic of people visiting their store. What this means is that the store cannot tell what proportion of their visitors are kids, youngsters, adults, or senior citizens. Similarly, they cannot tell what proportion of their visitors are male or female. Now you might wonder why this information is of concern to us. Let me explain this with an example here of Amazon Go stores. Amazon is developing its own Amazon Go retail stores, which is essentially an offline shopping experience they are giving to their online customers. And because they are already having tons of demographic and purchase history data on their online buyers, they are able to predict what their offline store visitors would want. So they are able to keep a minimal set of products in these stores, saving significantly on inventory costs, while achieving almost 100% conversion rate and higher ATV, which are critical to any retail store. Traditional retail stores have a lot to learn from Amazon on how to be data driven with their decision making. And the first step on this journey is to have data on their store footfall. So the next question is, how do they do it at scale? This is where deep learning based computer vision comes in. With computer vision, the store can capture rich data on their store footfall around age groups, gender, emotion, as well as time of visit and frequency. This information in turn may help in intelligent inventory planning, redesigning store layout, as well as launching store offers and advertisement campaigns, with an ultimate goal to improve conversion rate and average transaction value. Needless to say, this solution is immensely scalable and industry agnostic. Now let me introduce you to our dummy client ABC Supermarket's business case. Our client ABC Supermarket intends to capture demographic details specific to age, gender, and emotion on their store footfall. And the business intends to use this information for better inventory management, planning store offers, and advertising. As we need to build ML models on age, gender, and emotion detection here, we would need tons of labeled image data for training. A lot of such labeled image datasets are readily available on the internet, including CK+, UTK faces, IMDb wiki, labeled faces in the wild, facial age, and all age faces, to mention a few. From a representation standpoint, this is how these datasets look like. CK Plus is widely renowned as the most extensive facial expression dataset. As you may see, it has labeled facial images on facial expressions including happiness, sadness, surprise, disgust, anger, and fear. Next up, we have UTK faces that entails labeled facial images on age, gender, and race. IMDb Wiki, as the name suggests, is prepared by sourcing images from IMDb and Wikipedia platforms. And similarly, we have these other datasets consisting of facial images capturing details on age, gender, etc. In case you want to read more on these publicly available facial image datasets, here's a crisp summary sheet we have for you. You may pause this video here and go through this sheet. I'll provide these dataset source links in the description part below. For our project, we would combine UTK faces and facial age datasets together for age prediction, UTK faces for gender prediction, and CK plus for emotion prediction. A word of caution here would be that not all of these datasets are available for commercial use. For real client implementation, we might need to spend more time in identifying or buying labeled data that comes with a commercial use license. All these datasets provide us images that have already been cleaned and labeled, allowing us to skip the tedious data cleaning step of this workflow. Good for us, right? Let's go further. Alright, this is my favorite part where we design a high-level solution architecture to solve our client's business problem. From a 30,000 feet, this is how our solution architecture would be like. There's a camera at the store entrance capturing picture of a person entering the store. This image is then fed to the computer vision system where our age, gender, and emotion prediction models would be deployed. For this input image, all three models shall be called out one after another, and the final outcome on age, gender, and emotion is stored in the store databases for later analysis along with timestamp. Looks like one hell of an architecture, right? Let's go further. As we are working with image data in this project, it is important for us to know of the challenges we face while working with images. Images are essentially unstructured data that requires a lot of effort in pre-processing and feature extraction if you are taking traditional machine learning approach. In case you have gone through our face recognition project already, you would know what I'm talking about. Thankfully, in this project, because we are using deep learning convolutional neural network or CNN, we don't have to worry much about pre-processing or feature extraction, as CNNs are well suited to handle it on their own. This brings us to our next question. What the hell is a CNN? In deep learning, a convolutional neural network or CNN is a class of artificial neural network most commonly applied to analyze visual images. Convolutional networks are inspired by biological processes that happen in our human brain. So, intuitively speaking, just as children start recognizing objects in their surrounding as they grow up, CNNs also learn to make accurate detections given they get enough labeled data for training. To learn more on CNN, I strongly recommend you to watch this video by Dhaval, in which he explains CNN in a fun and intuitive way. I'll provide the link to Dhaval's video in the description part below. Now, when we are on top of our solutioning game, let's get straight into the machine learning part of our project. This is your free SkillKit do-it-yourself DIY toolkit that entails training datasets, source code, and client solution presentation. Link to access these files is in the description part below. Let me take you through the structure of this toolkit now. These first three folders, 1.1, 1.2, and 1.3, are input-output folders for age, gender, and emotion models respectively. Each of these folders have subfolders named input and output. The input folder has all the things that go in as input for training ML model. As you may see, for this age input subfolder, we have training datasets here as well. Similarly, the output folder has the CNN logs and the final model file that we use for predictions. We have kept pre-trained model files here already. So if you do not want to train your own model, you may use our pre-trained models directly. The same structure is followed for all three folders 1.1, 1.2 and 1.3. A word of caution here. Training your own model would require a high-end machine with a GPU. You may also use Google Colab Pro, which offers online infra with a GPU on a paid basis. If you have any questions around this, post them in the comment section below. We would be more than happy to help. Moving on, this folder 1.4 has a collection of test images that we shall use for age, gender, and emotion detection using the three model files from the respective output folders. Moving on, this 2.1, 2.2 and 2.3 are the source codes for training age, gender and emotion models. You would need to run these in your machine or on Google Colab to train your own models. We would be making separate videos to take you through these source codes. In this video, we shall use the pre-trained model files directly from the output folders to do predictions. And to do that, we have this 3.1 prediction file here. Let's open it and get started on age, gender, and emotion predictions. Now we are in Colab. Just to summarize, we already have pre-trained age, gender, and emotion model files in output subfolders of age, gender, and emotion folders. With this prediction code here, we shall use our pre-trained models to detect age, gender, and emotion on test images from the test input folders from our DIY toolkit. Alright, let's go section by section now on this code file. First up, we need to link Google Drive to Colab to access our project folder hosted on Drive. Let me run in this first cell here. You would need to authenticate on your Google account like this. Alright, we are done authenticating. Next up, we define our working directory with this next cell. ls command lists the files and folders we have on the working directory, as is the case here. Alright, the next section is for importing essential libraries. Let's run it. Up next, we need to load our pre-trained models on age, gender, and emotion. With this first cell here, we are loading our age pre-trained model. With this second cell, we are loading our gender model. Last one is the emotion pre-trained model. Let's call this one too. Now with this next cell, we are defining our labels. This we are doing so we may have fairly descriptive detection results rather than zeros and ones. This next section is where we are loading test images. You may uncomment any one of these images at a time to check model performance. Let's go with this first picture here. It's already uncommented. This next cell displays the picture that we loaded. Alright, so this is the picture we are feeding to our three models. Now congratulations to you for making it this far. With this next section on results, we would get to see what we are here for. Let me take you through what's happening here in this code cell. First of all, we are loading this har cascade frontal face file. Har cascade is a very popular algorithm for identifying faces in an image. This file is available on GitHub for download. In our case, I already have it in our toolkit folder, so we are picking it from there. Once har cascade identifies all the faces in an image, which would be one beautiful face for our current image, a for loop runs on all the identified faces. Under this for loop, detected faces are fed to age, gender, and emotion models, and their responses are recorded. And final output shows model responses for all faces. Let's run this cell now and see what we get. As you may see, our model has detected age in the range 28 to 45, which seems fair. Gender model detects a female, which is correct. Emotion model says positive, which seems fair as well. What do you think? It's awesome, right? As we discussed multiple faces a while back, let's try a family group photo now and see how our model performs. Let's uncomment this family photo link here and comment the other. Let's run all the cells after this. As you may see, we see 4 faces this time around. 1, 2, 3, 4. Thanks to har cascade. For number 1, our model says male 46 to 65 positive, which seems fair. For number 2 and 3, again the predictions seem fair. And finally, our model does a good job with predictions on this teenage girl face as well. I mean, how cool is that? Alright, the coding part ends here. As we were working all this while for our client ABC Supermarket, who wanted to build a computer vision based customer profiling model, let's go through our client presentation that we need to make to them for this project. So our scope was to train CNN models on age, gender, and emotion detections. This is the high level architecture for the customer profiling model that is to be built. Next, we tell them details of the datasets we used and the prediction labels for age, gender, and emotion. So this is our final deliverable to the client, which is essentially the three CNN models. Model accuracies for age, gender, and emotion are 83, 90, and 97% respectively, which is solid. We also keep exhibits on our model results. Here's one on a single portrait. Here's another one on a group picture. Towards the end, we may ask them to give us more business in terms of getting CV-based customer profiling solution implemented by working with their hardware vendor. We can also offer them to own the entire data-driven improvement piece for their retail business on a medium term. Alright then, this completes our age, gender, and emotion detection project. Hope you had fun all along. We post new machine learning project videos every month, so make sure to subscribe to our channel if you haven't till now. Good luck to you. Bye.